Imagine sunlight as a stream of tiny messengers. Each one carries energy. A solar panel is a quiet factory. It turns that energy into electricity. You see blue glass on a roof. Beneath it sit wafers of purified silicon. Silicon is a tidy crystal lattice. Electrons sit in orderly bonds. When a photon hits with enough punch, it frees an electron from that bond. This creates a pair called an electron and a hole. One is negative and one is positive. Left alone, they would quickly recombine, so engineers build a p-n junction. That junction has a built-in electric field. It pulls electrons and holes apart. Electrons flow one way through the crystal, holes drift the opposite way. Metal contacts collect those charges. Now a current can flow through a wire. That steady flow is direct current or DC, small, but incredibly useful and clean. To raise voltage, you connect cells in a line, positive to negative. This is called a string. Then, to raise the total current, you connect multiple strings together in parallel. A typical panel packs many cells. Together they can reach tens of volts. Real sunlight is a moving target. Clouds and angles nudge power up and down. An MPPT controller is a smart gear shifter. It keeps the panel at its sweet spot. Most homes run on alternating current or AC, so an inverter flips DC into grid-friendly AC. Safety matters when shadows appear. Bypass diodes let current detour around shaded cells. Temperature affects efficiency more than you think. Hotter panels lose a little output. Orientation and tilt matter too. Aim panels toward the sun for your latitude. Manufacturers rate panels at standard test conditions, bright sun at a set temperature and spectrum. Wiring and losses shape your outcome. Short, thick cables reduce resistive heating. Some systems use string inverters, others use microinverters on each panel. String inverters are simple and cost-effective. Microinverters handle shade on a per-panel basis. Add storage to keep power at night. Batteries soak up extra daytime energy. Some homes feed excess to the grid. Net metering credits can lower your bill. So, follow a photon on a sunny day. It lands on silicon and sets carriers in motion. Current leaves the panel as DC. It flows into the inverter cabinet. Electronics sculpt a perfect waveform. Out comes synchronized AC for your home. Your fridge hums on clean solar power. Lights glow with energy from the sky. If you make more than you need now, batteries charge, or the grid takes the surplus. As the sun sets, production tapers, your home draws from batteries or the grid. This is the photovoltaic effect in action. Light energy turns directly into electrical energy. There are no moving parts to wear out. There is no fuel to burn. The transformation is silent and steady. It keeps working as long as the sun shines. Care and longevity matter for performance. Keep panels clear of dust and debris. Clean glass lets more photons through. Even small shadows can cut output. Check mounts for wind and weather. Good hardware keeps panels secure for decades. Efficiency inches upward each year. Placement and wiring still matter most. Here is the big picture made simple. Panels are light catchers and wires are energy highways. Cells separate charges and push them along. Inverters translate the flow for our homes. Controllers track the sweet spot all day. Storage saves the excess for later use. You tune the system with thoughtful placement. The sun does the heavy lifting for free. Electric fields start the carrier motion. Circuits collect the flow as useful work. And that is how sunlight becomes electricity, clean, quiet, and ready every clear morning. If this made solar feel simple and powerful, like and subscribe to explore more science with us.